Hello everybody, welcome to the 2022 Robotboat Team Competition Strategy video for UM Autonomy. The purpose of this video is to share how we as a team plan to tackle the Robotboat competition in June and share a little bit of the story about how we came to the decisions and strategies that we did. So, to start off with a little bit of background, while it was amazing to be on campus, we'd also like to share a lot of our struggles of coming back to campus from such a hiatus. From conversations with other design teams on campus, such as RoboSub, we realized that many student teams were running into the issue of past knowledge being lost or not passed down. As members graduated or left the team, they didn't always pass down knowledge or document everything perfectly. So we found ourselves doing a lot more research and relearning how past members completed their projects on our own. This took a lot more time and energy than we initially realized, and these struggles really shaped the way we designed our boat and operated as a team, as you'll see later in the video. Starting off with our boat itself, you may notice that it looks very familiar. Initially, we had very ambitious designs for our boat, and perhaps we were being a little bit too ambitious. Our initial design was of a catamaran design with two very large hulls. The naval architects wanted the larger boat to be just under 6 foot long and just under 3 foot wide. And we would have connected the vessel together with all this carbon fiber tubing and a carbon fiber superstructure. However, as delays from design, COVID, and uncertainty of how the year would play out, we found ourselves, missing a lot of deadlines and being worried about whether or not we would have something that even floated. And as we were going back through the history of UM Autonomy and looking at how previous naval architects built the boat and what boat designs took into account, we realized that this older design from our boat called Flying Sloth 2 sort of fit a lot of our needs, and as we were missing these deadlines, we realized that for the sake of getting into the water, it may be the most beneficial to go with an older hull design and sort of just build off of that one, make large improvements here or there, and sort of just take an initial design that we know worked and sort of just upgrade it in every sense that we needed to. So if you look on the screen, you'll see a video of us sort of working on that initial boat and sort of stripping it down to its bare bones and then sort of building it back up based on our needs and our thrusters and whatnot. As of right now, we are still actually working on the superstructure of the improved version. This superstructure is essentially going to be holding a lot of our sensors, equipment, and mounts and whatnot, but it'll also sort of tie the boat together and make it look like a very cohesive unit. From the monthly Roboboat meetings, it was clear that we would be given much more time to test on the water, and what would limit us in terms of testing would be ourselves. As a result, we designed our electrical system to reduce the amount of downtime we had between runs, and our battery swap design would be very beneficial towards being out in the water for as much time as possible. The way our boat is powered is through two LiPo batteries. Both rechargeable batteries power the system, but the system can also run off just one battery. Looking at the video on the screen, the boat is running on two batteries at the moment, with one battery charging in the background. So as soon as the indicator shows that one battery is running low, we can quickly swap in a fully charged battery and get the depleted battery charging, all while not turning off the computer. So during competition, we would have two batteries powering the current boat in the water, and after each run or each lap, we would bring the boat back and take a look at how the batteries were doing from the indicators. If we see that one of the batteries need to be swapped out, we can take one of the charging batteries and throw it in, or we can quite simply just keep the boat in the water and then have it do more laps until the batteries are depleted. On the shore, we'll always have two batteries charging, and they'll be ready to swap whenever a battery on the boat is failing or running critically low. So while all this is happening, the boat never has to be turned off, as there's always some form of energy flowing into the boat. So looking at these specific tasks our team wants to prioritize, we want to focus on completing the navigation channel, avoid the crowd, find a seat at the show, and snack run the most. After that, we would consider the water blast challenge and especially the skee ball challenge to be sort of reach goals for us. For all of our members attending competition this year, this will be their first competition, so we consider the journey and experience of being there and testing in person to be a major win for us. This means that the completion of just a few of these challenges and the ability to see our hard work in action is what we'd consider a success for the team. And last but not least, we just want to thank all of our sponsors, from the College of Engineering to our corporate sponsors over at Ford, Boeing, Aptiv, and Northrop Grumman. Without their support, we wouldn't be able to do the amazing things that we do, and we hope to continue seeing them support us in the future.